Hey guys, let's work out a few problems from time and work today. The first question is this. A, B and C can complete a piece of work in 20, 15 and 12 days respectively. They started the work together but C left after 2 days. In how many days will the work be completed if B leaves 5 days before the completion of the work? Let me work it out using LCM approach. You can also try out for yourself unitary approach. Link of the video detailing both the strategies is given in the description below for your reference. Yeah, in LCM method, the first step is to choose the total quantity of work as the LCM of the number of days involved, which are 20, 15 and 12. LCM is obviously 60. So we take 60 as the total quantity of work to be done. The next step is to find out how much work A, B, C will do in a day based on this assumption of total work being 60. A does 60 units of work in 20 days, which means A does 60 by 20 equal to 3 units per day. Similarly, B does 60 by 15, 4 units a day. And C does 60 by 12, which is 5 units per day. This is the first step. So in LCM approach, we assume the total work as the LCM of the number of days involved. Thereafter, you find out the amount of work each one does on a daily basis. What is it that we are asked to find out? The number of days they take to complete the whole work. Let N be the number of days for completing the whole work. The work was started by all of them together. They started the work together. But C left 2 days after, which means what? He does only 2 days works. In one day he does 5 units. So in 2 days he will do 2 into 5 units of work. So this is what C does. Now look at the assumption. N is the total number of days rather they take to finish the work. And B left 5 days before completion of the work, which means B worked how many days? N minus 5 days, because totally they take N days and B left 5 days before. That means he is in the work for N minus 5 days. And how much work does he do in a day? 4 units. This is what he does in one day. So if you multiply by the number of days he works, you get the total work put in by B. Now come to A. A is in the picture from start to finish because only C left 2 days later and B is also leaving a few days before, rather 5 days before the completion of the work, showing A is in the work from start to finish and N is assumed to be the number of days. So A does how much work per day? 3 units and he is working for N number of days. So 3 into N will be the contribution of work done by A. Now we have found out individually the contribution of work done by all the 3 people, and if you sum it up you get the total work which is assumed to be 60 in our solution. Now you got a simple equation, just solve it, you will get N. This implies 10 plus 4N minus 20 plus 3N equal to 60. 4N plus 3N is 7N and 10 minus 20 is minus 10. Take it to the other side, you will have 60 minus 10 on the left, on the right it becomes plus. So 10, which means 70. This implies N is equal to 70 by 7, 10. And what was N? The total number of days. And what is it that we are asked to find out? The total number of days they take to finish the work. So this is the final answer to that question. Let's do one more problem from time and work. The second problem is this. B can do a piece of work in 30 days. A is twice as fast as B. B started the work and A joined him after a few days. For how many days did A work with B if the work is completed in 15 days? As you can see, there are 2 people. We know the number of days B alone takes to finish the work, given to be 30. Now they say A is twice as fast as B. What does that mean? A will need half the number of days taken by B to finish a given piece of work. So A will take 15 days to finish the same work. Now let's use a LCM method. There, the total work to be done will be taken as 30 units, which is actually the LCM of these two number of days. Now using this assumption, how much is the work A does in 1 day. See, total work is 30, for which A needs 15 days. So he will do 30 by 15, which is 2 units in 1 day. So he does, A does rather 2 units per day. Similarly, B does 30 by 30, which is equal to 1 unit per day. Now we are asked to find out how many days A and B worked together. See, B is in the work right from the start, and the work is said to be completed in 15 days, which indicates B has worked 15 days. Whereas A joins him after a few days. Let's assume that, let N denote the number of days A worked, or you can say that A and B worked together. A working is the same as A and B working together. Okay. Now let's work out the contribution of work done by each of them. Look at B. B has worked 15 days. As you can see, B is there in the work right from start until it's over, and it's getting finished in 15 days. So B has worked 15 days. And every day he does 1 unit. So 15 into 1 is what B has done totally. Now let's work out total amount of work A has done. A is assumed to have worked n number of days, and per day he does 2 units. So n into 2 will be the contribution of work done by A in the work totally. So this is what B does totally, this is what A does totally. So the total work is over, and the total work is assumed to be 30. You got a simple equation in n. Let's solve for n. So 2 into n into 2 rather, 2n. Take 15 to this side, 30 minus 15, which is equal to 15. So 2n equal to 15. So n is equal to 15 by 2, which is 7.5 days. So 7.5 days is the number of days A has worked in the job, or rather A and B worked together. Both mean the same thing. After A joins, B is not stopping to work. So the number of days A works will be the same as the number of days A and B together work, which is what we are asked to find out in the problem. So 7.5 days is the number of days A and B work together. Let's do one more problem in today's session. A, B and C can complete a piece of work in 20, 15 and 12 days respectively. They work on rotation with A starting on the first day, B on the second day, C on the third day, and A again on the fourth. Find the total number of days taken to complete the work. Let's take 60 as the total quantity of work to be done. 60 is just the LCM of these three number of days. Now, A does 60 by 20 equal to 3 units per day. Similarly, B does 4 units per day, 60 by 15. C does 60 by 12, which is 5 units per day. Here they are not working together on the same day. Instead, A works on the first day. So on the first day only so much work gets done. Again, A leaves the stage and B will take over, and B does 4 units on the second day. So only 4 units. Then B leaves the picture and C will take over, and he does 5 units on the third day. So totally in 3 days, the amount of work getting done will be 3 plus 4 plus 5, which is 12 units. This is done in 3 days. Usually so much work will get done on a single day when all the 3 people are working together. Here they are not working together. Each person does whatever he can on the first, then the second person on the second, and the third person on the third. So in 3 days, 12 units of work will get done. So in 3 into 5 days, how much work will get done? 12 into 5 units, which is 60 units, which is actually the total work to be done. So in 15 days, 3 into 5 is 15 days, 60 units of work will be getting done. Rather, 15 days is the total number of days they need to complete the entire work. So today we have done totally 3 problems based on the concepts which I have already covered in the previous video, whose link is given in the description below for your reference. If there is any step you are unable to follow in any of these problems, feel free to raise it in the comment section and I will address it there. See you guys in my next video, where I will help you with smart solutions to problems that are even trickier than this. Bye for now.